Hey, are you too padhaku like us who loves to learn new things and gain knowledge? Then this is the right source for you. Make sure you subscribe to our channel to never miss out on any update and like and share our content with your friends.
So there are some things that we will be covering in this session. So there are some techniques that are basic and intuitive for you to learn. So what we will be doing is we will be going through some of the basic prompt engineering rules and techniques, and we will be implementing it on the OpenAI's playground, and we'll play a little bit around it to have a better learning. So let's start with what is context and how in context learning is growing with time. So as you all know, in the GPTs there are different versions like GPT-1, GPT-2. So I remember GPT-2 came around 2018, but it was not popular then because the results were not quite impressive. The main reason behind that was because the number of parameters that were given into that model to get it trained was quite less. As you can see, 1.3 billion parameters were from GPT-2, and the accuracy percentage is even less than 10%. So with time, the machines became stronger, and we had more and more data points. So we were able to give the next model that came was with 13 billion parameters, and the accuracy was improved. And post that, the GPT-4 that you guys are working on right now, or I guess most of the people are working on, is trained with 175 billion parameters. And as you can see, with a rise in number of parameters, the accuracy has also risen to 60-70%. So this is just a graph to help you understand how things are working with the rise of parameters. So said that I have a model which is being trained with 175 billion parameters, and the accuracy is 60 to 70%. Now comes the role of how you are able to tweak or how you are able to increase this accuracy, given that this is the number of parameters that I can train my model with. This is fixed. This is a basic constraint. Now to increase the accuracy, we are left with the prompt. So these are two things. If you see, if I am giving no prompt, with the rise in number of context. So to help you give example of what context here is being referred to. So when you are saying, hi GPT, I am having a problem in writing a mail, can you write me a resignation mail? So this is basically a context. If you see, this context is very small, it must have been of 15 to 20 words. So if the number of words that are given in terms of context are less, and then there is no prompt being given, the accuracy is generally lesser than when natural language prompt is given. But this is only the case when the number of things or number of words in the given context is less. So context is basically the question that you are asking with the GPT. That is basically the context, and if that context is not in detail, so let's say I am writing two examples of prompt context, I'll say. One is, write me a resignation mail for my CTO. This is one example. And second example is, hey, I am Piyush. I have been working for 2 years in this company, uh, and recently I have been not feeling well. So please write me a mail for my resignation. This is another example of context. So you can see there are differences in length of context, and first one is very brief, and second one is a little larger where I have given more information to it. So now here comes, so by default, if you are giving these context without prompt, so one context will lie somewhere here and another context will lie somewhere here, which is having more context. So as the graph suggests, if you are giving in more and more context, so the accuracy is somewhat equal to when there is prompt or when there is no prompt. But the main thing is, the people don't want to interact that loud or don't want to give that much of information to the context. So there comes the role of learning how important the prompt is. The main reason being, you can see the difference. When there is no prompt, the accuracy is quite less, whereas when there is some prompt, the accuracy is a little bit higher. So this graph is just to have you understand the importance of prompt when the size of context is a little smaller. Any doubts so far in this? I know it's a little complex to understand, but just see through the graph and try to understand what a context is and what a prompt is. This is just to show you the importance of prompt, nothing else. Okay, Swastik or Aditya, can you just unmute yourself and let me know what exactly is the thing that you are not able to understand? Today we have a little less participants, so it's possible we can have an interaction. It was clear. Okay, no doubt. Oh, I got it.
Great
Okay.
job, guys. As Piyush mentioned, like feel free to unmute yourself. It's going to be very helpful because this is the like we have kept the audience less this time because we want to be you to be like participative, and this is going to be very helpful for you. Yeah.
Yeah. So let's go to what exactly a prompt is. Prompt basically is a thing that involve instructions as well as context, which is then passed to a language model to achieve a desired task. And I guess this is pretty much clear because you guys are here for prompt engineering. So the definition of prompt must be clear to everyone. And if I say the prompt engineering is basic practice of developing and optimizing prompts. And what we are achieving by doing that is we are able to efficiently use the language models for a variety of applications. And this is just a highlighted definition which was generated by AI. So I just put it here for reference. Then why prompt engineering? As I have already discussed you with the help of diagram, the importance of prompts. So let's understand importance of prompt engineering. Uh, it is important for research discoveries and advancements. So let's say if you are given an LLM and you are just giving it more and more data, so you should be able to understand what kind of data is needed by the machine a little more. So let's say I am developing a model that is for helping me do the codes. So I should be able to know, right, how much data is required by that model. It should not be like I am just giving it in a redundant data. So let's say I want my machine to reply me some JavaScript or some Python codes, and then I should be able to, like, I should be knowing how much data should be given to the LLM or to the machine, so that it is able to give me correct outputs. So for that, when there is research being done, or when we are training a new model, that is the point where prompt engineering is required. So here a screenshot of Anthropic is also mentioned. So Anthropic is one of the organization that has launched a model that is Claude. And the main advantage of Claude is it is helpful in like interpreting things and analyzing things. So also the plus point is the Claude's token limit is 300K. And if you guys knowing that OpenAI's GPT models having a token limit of 32K as of now. So that is another difference. So if you go on the website of Anthropic, it's anthropic.com only. You will be able to see there is this job opening. I am not sure if it is open now, but there was this job opening, and you can see the salary ranges 250 to 335K, and that's a huge amount of money. If I'll say in Indian terms, it will come out to be nearly 80, 160, nearly 2 cr. It will come around 2 cr to 2.5 cr. So that is the amount of money we are talking about here. And The main reason is most of the people are just new to, like, this whole concept of prompt engineering is a little new, and the demand is higher but the supply is low. So if you guys are able to understand in prompt engineering, like in this session I'll be just able to give you a glimpse, but you there are our courses where you can come and understand the basics of prompt engineering, and then you can just have this open market where you can just go and get a job. Now we will be coming to parameters of decoding. This is a little complex to understand, so I'll just recommend to stay with me and understand the gist, if not able to understand each and every specifics of what we will be discussing here. So there are some types of search, and greedy search basically signifies that the kind of output you are desiring, just write that, and you will be able to get the count. So for a little example that I'd like to give you is, let's say there is a problem statement. You goes to a shop and you gives him, let's say, 500 rupee note, and you bought a 10 rupee candy. So the problem here is, the shopkeeper wants to give you change, but he has a constraint that he wants to give you least number of note or currency notes. So in Indian currency, there is a system like, you can follow the greedy mechanism. That is, let's say he gives you two 200 notes, and then 150 note, and one or 220 notes. So if you see, what I am basically doing here is fulfill the number of notes which are having greater value. So giving you 500 rupee note in return was not possible. Next denomination to 500 is 200 rupee note, and for if you are able to fulfill 200 rupee note, that is because we have to return 490 rupees. So we can just give you 200 rupee note, so that will suffice 400 rupees, and then you can suffice 90 rupees using 150 and 220. But there are currency systems where this approach is not possible. So if you I give you one example. uh, uh, yeah. So let's say there is a system where there do not exist a 100 rupee or 200 rupee note. There exists a 400 rupee. Huh. So there exists a 400 rupee note, and there exists 110 rupee note. This is a currency system. So in this case, the possible there also exists a 200 rupee note, or I would say 40, 90 divided by 30. I'll just give you one reference. You can see over here. This is actually a little important to understand if you guys are not from coding background. For coding background people, it must be a very easy problem. Currency. Currently, we are talking about Indian system. 200, 500, 200, 100, 50, 20, 10. Whereas there is another currency system where the currencies possible are, let's say there is 500, there is 400, then there is 200, or I would say 390, and then I have 100, and then 10, 50, 20, 10. Yeah. So what I have done here is I have introduced these two currencies, these two new currencies, and for the problem that we were having, that is we have to return 490 rupees. So for Indian system, it would be I am approaching a greedy, that is take the highest denomination. So now that comes 500 rupees. 500 rupees is greater than this, so that is not possible. Let's pick 200 rupees. 200 rupees is possible. So what I'll be doing is I'll be putting in 200 rupee max note. That is possible into 2. So that gives you 400 rupees. Now left is 90 rupees. Let's take 100 rupees. That is not possible. 50 rupees. That is possible. Let's take 50 into 1. Now the left amount is 40 rupees. So for 40, 50 is not allowed. 20 is allowed. So this way I am able to get my 490 rupees back. This is only possible for a structure with Indian rupee system. So let's say there exists hypothetical currency system. Let's group it. Keep it here. For this kind of currency system, let's again approach it with the same algorithm that we were looking. We have 490 rupees. We will pick 500 is not possible. We will pick 400 rupees. This is why a greedy approach. 400 into 1 is 400. Now left amount is 90 rupees. For 90 rupees, 390 is not possible. 100 is not possible. 50 is possible. 50 into 1 is 50. Let's say there is not 20 is also not there. So now what I am left with is 10 into 4 is 40. This way I am able to achieve 490. Now if you see total amount of nodes that is used here is 6. But ideally, let's say I give you one solution of this manner: 490, 390 into 1 is 390, and then there is this 100 rupee note. This way I am able to get 490. But this is not the greedy approach, because I have not followed the top to bottom approach. If I am following greedy approach, I require like 6 notes to fulfill 490 rupees. But if I am not following greedy approach, but I am a little smarter, and there is this different name for this approach, but let's just not go through the names, that will cause you confusions. But if I'm not following the greedy approach, you see, right, I just need 2 notes. So this is the problem statement here that I was discussing actually. That is, mm, split represent. Yeah. So greedy or beam search is a kind of similar search than greedy, generates less surprising or boring responses. It is possible that greedy approach sometimes fulfill your requirement, but it is not always that a greedy approach or beam search will generate you the required responses. So it is not like there is a proper statement or a proper research that has been done that states that greedy approach will give you the required output, but in a little, or I can say, let's say you give it a problem like give me 2 plus 3, it will be able to give you 5. Just give me a second, like guys, I'll plug in my charger. Sorry guys. Yeah. So what the research states is basically for greedy, sometimes where you need, let's say you have a problem statement that GPT generate me a 200 word paragraph for, let's say, discussion on elections. So or just give me some dialogues or storytelling. So greedy approach is basically not good for these kind of tasks. And majorly the LLM was first of all generated for creating content and show its creativity. So if you just expect the LLM to give you results for 2 plus 3 or like direct results, let's say correct the grammar, or these are the basic things. For these things, LLM, you are just wasting power of LLM because there are very small models. If you have used Grammarly is working on a very cheap model. It can also give you grammar suggestions, right? So these are some of the tasks that can be fulfilled by other models also that are cheaper to use. But if you are using a great powered LLM, main task is showing its creativity. And for creativity, greedy or beam search do not always works. That's why when you guys write prompt, right? So just stating that this is user, user will ask you some questions, give him the answer. So this is very straightforward and greedy approach, but it won't be able to give you very good like creativity based answers. So now we will be studying a bit on sampling. So how sampling works, just ignore this diagram because it will make you confused. We will be discussing this when we will be discussing some of the techniques of prompts or prompt engineering. Now, it is important for you to understand there are basically two more parameters which you can use along with your prompt to control how GPT is responding. So one thing is temperature, one thing is top P. I'll stop my presentation here and will like to understand from you guys. If anyone knows what is top P or temperature. Yeah, Nikhil, you want to answer? Aditya, you got the answer right. 390 plus 100 was not from greedy approach, but this was a little smarter approach for you to get the answer. Yeah, thanks. What is LLM? I guess it should be clear. I won't be discussing. Aditya, can you answer me what is TOPI or temperature? Anyone
Please, can I answer
know?
if I'm not wrong? I don't know exactly, but I think it's temperature is the like how much like uh, how much we want to like be what do you call it, like uh, height or the strength of the like LLM, right? That we want to use.
Yeah, you are on a right track. So basically, temperature controls the randomness, and top P controls the repetitiveness of a thing. So if I go through the technical definition, so these are just the basic definition of on a broader basis. Like temperature controls randomness, how creative or random you want your output to be, and top P basically controls the repetitiveness. So there is a possibility that when you are generating text, a single word that GPT is able to create, it is repeated too many times. So to get a little more into depth, temperature controls sharpness of next token distribution. So you have a given token, and the next token will be created on the basis of all the tokens that are being there. So, like, just to understand on a broader basis, you can remember temperature as a parameter of randomness. The value between 0 to 1 for a standard model, it is from 0 to 1, but recently GPT-4 came, and GPT-4 is having value for 0 to 2. So it has increased from 1 to 2 because it is dealing with a large set of data points. That's why the value is being increased. For you to understand, lower the temperature, the sharper distribution and repetitive generations. If you want to remember it, like 0 indicates more and more precise text output, and 2 indicates more and more random output. And same, like we will be trying this out in the playground, where I will be showing you what is the power of 0 and what is the power of 2. And when you are like tweaking the things, you want like some of you have questions, let's have it 0 or let's have it 2. Why is it having a range from 0 to 2? We will be also seeing that same parameter is top p, its value is from 0 to 1, but nowadays there are models which is having the value from 0 to 2 also. And again 0 represents less, smaller p, yeah, smaller p represents repetitive generations, so it's a little opposite to that of temperature. And so basically ideal value for top p is also 1, and ideal value for temperature is 0. But then again there is as such nothing ideal because it varies from case to case. We will be learning like understanding these two parameters in more details when we will be going through the playground. Now let's understand the basic prompts. uh, if you guys can help me understand what are the basic four components of a prompt. This is just a basic prompt that is written here, but can anyone help the four components of prompt if you guys have attended any other session or webinar on the prompt engineering? Okay, so these are four elements of a prompt. This is nothing, this is just a prompt we'll be studying in detail. So first of all there are instructions, then there is context, then there is how the input data is, and then there is output indicator. So if you see, this is an example of a prompt. Instruction is classify the text in neutral, negative, or positive. So what basically you are expecting your model to do. Let's say you are creating a chatbot, and that chatbot is running on the AI, right? So you want your chatbot to respond like a teacher. So let's say the instruction can be you role play as a teacher, where student will come and ask the questions and you will reply with the answers. Context will be user question. Input data can be something like hi, I am a 10th standard student. I am facing a problem in learning mathematics. This can be input data type. Or output indicator can be like you are a teacher and respond it very politely, or you can also say answer the student in step by step manner. So these are some of the things that you can give. But to understand the prompt engineering, these are four components that you should keep it in your mind. Instructions, context, input data, and output indicator. Let me know if it's clear, because going forward we will be referring to it again and again. I'll just give you 2 minutes to digest it, and you can just take a pen and paper and note for these four of these headings for you to remember, or you can take a screenshot or take a photo from your mobile. Yeah, let's continue. So I guess let's first also see temperature and topic, or we can keep it later. So these are two parameters that you should keep in mind, and I guess this is a broader basis. We will be looking at a little later. Yeah. So now comes first of all, for understanding prompt engineering, you should be understanding what are different use cases a LLM can be used for. So LLM is just a model on which you will be giving the prompt, right? So um, I have just classified the tasks into six things that LLM is good for and is research for. So there is text summarization, question answering, text classification, role playing, code generation, and reasoning. I guess these headings are self-explanatory itself, but let's go into deep. So for text summarization, the role that LLM plays here is you have some large text. This is a smaller text, so it's quite obvious that it will be self-human readable. But let's say I'm talking about a PDF that is having 100 pages of text that is there. So that is a large amount of set, and I'm not a Microsoft suits, right? That I remember everything of what I have read. So for that, Chat GPT or LLMs basically come into picture. And as I have talked about earlier, also there is a model that is Claude. So Claude is basically having its expertise in text summarization. You can give it a large amount of text, up to 300k tokens, and it will be give you whatever question you have out of it. So this is one of the role of the LLMs or the models, that is text summarization. Another thing is question answering. So as you guys know, the LLM is being trained with one, like billions of parameters. So it is already having some amount of knowledge. So if you will just go over the chat GPT and ask what is React, what is JavaScript, what is Python, or teach me Python, it already have that knowledge that what is Python, what is JavaScript, correct? So it have already some kind of understanding. Now if you'll just ask some questions, so let's say the question here is answer the question based on context below. So this is basically the prompt for this model, and the question is what was OKT3 originally sourced from, and answer is mice. So this is a prompt, that is these are input indicators, the role play, and then this is the context and output indicator. Now comes the text classification. So text classification can be understood on the basis of these three things, but there are different kinds of classification that is present here. So let's say, take an example of there is a boyfriend and girlfriend having a chat over, let's say Tinder, and I want to predict whether there is a chance of hookup or not. So let's keep this interesting story in our mind. And one thing is, we as human just go through that chat, and we have some of our prejudices, right? कि भाई इसने ऐसा कहा तो ऐसा होगा, ऐसा कहा तो ऐसा होगा. तो we are able to give our judgment कि इन दोनों का होगा या नहीं. But let's say similar task, or you can take an important example here also. There is a court case that is going on, and there are some of the evidences that is given by support and opposition. So there is this last day of judgment, and you want it to be automated by the AI. So you will just give in the whole statement of what all evidences have been submitted and what all are the hearings, right? So that is the kind of abilities of LLM, the classification that it can do or make decisions. So that is the thing. And for the prompt here, if you see, it has written just a single line: classify the text into neutral, negative, or positive. And the text I have given is, I think the food was okay. The sentiment is neutral. uh, the sentiment analysis, why it's important is, like when you are creating chatbots, to understand this a little better is important, because sometimes when you are creating, let's say, support chatbot or marketing chatbot, for marketing chatbot you need your the LLM to respond in a joyous manner. Or let's say when you are creating a chatbot for customer support, you may be wanting your chatbot to be of supportive nature, or let's say it should be friendly, and it should be able to calming for the user. So understanding the emotion of what all chat has been going on is actually important, and that's why this text classification comes in. Then there is another game, that is role playing. As I have already discussed, like if you are creating a chatbot, you want your AI to role play like some other person or human being. So this is the basic prompt for, let's say, AI research assistant, and we have given the indicator also that assistant tone is technical and scientific. So understanding the tone here is important for AI, that we have seen in the classification. So this is the prompt for role playing, and hello, who are you? Since you have given it to act as an AI research assistant, it will reply as, "Hi, I am an AI research assistant. How can I help you today?" So this is another characteristic or classification of LLMs, that is role playing. Then comes the code generation. I guess it is quite obvious because there are various extensions like Copilot, Hugging Face, Llama. These are all the things that are in the market right now that are working on code generation or helping developers code faster. Last thing I would say is the reasoning. So I don't know how many of you remember, but during my days in the school, there was a book called R.S. Agarwal, and there were very serious kind of questions for mental ability. There were analogies that were there. So this reasoning is also, like, AI is also being proven that it is able to reason, right? So I just had a curiosity. I pull out my RS Agarwal one day and took some questions and asked GPT. GPT was able to give all of answers correctly. So that is the power of, I would say, LLMs nowadays. So reasoning can be of various types. One example is just mentioned here. The odd numbers in this group add to a even number. So you have to just give the answer on this, and the input that is given by the user is list of numbers. The sum is this, and GPT is able to give that 41 is an odd number. This is very basic of a reasoning, but yeah, complex reasoning is also nowadays solvable by AI. So any of you have any doubt on these six task classification for LLMs? Understanding these things a little better is more important, because if you don't know that AI is capable of doing this, you won't be able to write proper prompts. So I'll give you 2 seconds just to go through the headings of these and understand or remember, like इस चीज के अंदर ये है, इस चीज के अंदर ये है. I'll wait for another 2 minutes. Let me know if anyone have any doubts. Okay, I'll ask randomly 2 people for definition of some task. Ishan Jaiswal, are you there?
Hello.
Yeah, hi. Ishan, can you just help the audience quickly summarize what was text classification?
So it was classifying text.
Just give an example. Can you think of an example? I have also discussed one example. You can give the same one. Ishan, are you there? Uh, uh, yeah, I've shared the slide for you. You can take in reference from here and create another example out of it.
So sir, it's basically classifying the statements that we give into three categories, that is neutral, negative, or positive. So we can think of hello, hi, good morning. Today is a bright weather. Today is a nice weather. So it's a positive statement.
Exactly. So thanks, Ishan. Thanks. I now know that you have an understanding. Let's pick another candidate. Saloni Mehra, are you there? Uh, Saloni, are you there? Okay, I guess she's not there. Uh, Utkarsh Gupta, are you there? Utkarsh, are you there? Today's audience is not that good. Aditya Dharpalli, are you there? Guys, this way, if you are not responding, it's not beneficial for you to stay in the stay in the class. Okay, issue with my mind. Fine, Aditya, fine. Thanks for responding. At least you responded. Fine, then let's continue for the guys who are listening. Now we will be discussing some of the prompt engineering techniques that are there. I guess this is the most important thing you guys are here for. So there are five that are mentioned here. So first I'll be trying with few short prompts and chain of thought, and let's try some combinations of these two of techniques. And I won't be covering React and knowledge generating prompting here because this can be a little overwhelming for you. But if someone have interest, you can let me know. Let's understand few short prompts. So few shot prompting is basically a way where you give, let's say you expect your model to respond in some manner. So what you do is basically you give him some of the sample inputs. So here, like the prompt is odd numbers in this group. Like this is the sum of the chat that I have given to the model, and then I expect something out of it. So let's go to the experimentation mode right now. I hope everyone here is aware of this platform. Here you can come and try your prompts how it is responding. So just to give you a referencing, putting a link here also. So yeah, let's say I have a use case of maths. So I give student what is, let's create another language 1+1 assistant 11. This is the role play for developing language. So uh, let's say 2 plus 2, that is 22. Let's say 3 plus 3, that is 33. Let's say, so basically the plus sign here means concatenation. It will comes out to 14, 12. Now if I gives user input as what is 80 plus 2? Ideally, the result should be 802. Let's see how it gives. See, so this is an example of few shot technique where the kind of thing I am expecting from the system, I am giving it some of the examples, and he is able to give me the correct thing. So here, this is my prompt, and this is a user input, and this is how assistant responded. Ideally, if let's say this is not the prompt, I just put it, and I gives him 80 plus 2, it will be returning me 82. But let's say I have some example or some use case where I responded in such a manner, it will return me 802. Okay, 80 plus 2 will return me 802. So that is the power of how you can tweak your prompts, and the model will respond you in the manner you want to. So let's go back to this. Any doubts in few short prompts? I guess it should be pretty clear itself. Let's go to COT. So it's basically chain of thoughts. Uh, Chain of thoughts is responsible for chat completion, I'll say majorly. If you go through the definition, prompting can be further improved by instructing the model to reason about the task when responding. This is very useful for tasks that require reasoning. You can combine it with few shot prompting to get better results. You can also do zero shot. So we'll be talking about zero shot COT where examples are not available. So COT can be used with few shots or without few shots. It's basically like you can give the examples or you may just skip it. So the problem statement that is written here is, if you just see odd numbers in this group add up to an even number. Adding all these odd numbers gives you 25 and the answer is false. So let's go back to our platform and let's take one example. What example should we take here? Hmm, yeah. So the example is, give me the numbers. User will give you some number. You have to identify whether it is uh, square of some number and also cube of some number. Let's give it 30 as an input, or let's give it 4 into 4 is 16, add 4, 16. Yeah. Can anyone say what is cube of 2? Is it 16 or 8? 8, right? So if you see here, it is not responding how it should be responding. Now, if I like, this is the basic prompt that I have given it. Let's take another example. User will give you a number. User wants to know whether it is a perfect square as well as perfect cube. You can iterate overall possibilities of cube root and square root and check if it has some number on squaring or cubing you this output. Now I have mentioned like a little approach how it can do like this kind of computation, and now let's see what it gives. Again, it is not working properly. 2.5 होना चाहिए. Let's try. Square 64. Let's take 64. Yeah. So now if you see, sometimes it is giving me the correct output, sometimes it's not. So let's implement a little few shot here. You guys are able to understand what is a COT, right? Chain of thoughts. You have seen a simple example, and then this is kind of I have given it how you can approach this problem to answer. What I have written is you can iterate over all the possibilities of cube root and square root and check if some number on squaring on cubing is giving you this output. So this is an additional thing that I have taken from COT. Now what I will be doing is I'll be giving it some examples that is uh, you can combine it with few shot prompting. So now what I am doing is I am using few shots, some things of from few shots and some things from COT. So let's say if 16 is example, uh, cube roots can be 1, 2, 3, 4. Yeah, 3 तक ये हुआ 3 into 3 into 3 2 into 2 into 2. Yeah, so this, but 2 to the power of 3 is 8, not a cube root. The answer is false. If 64 is example, cube roots can be 1, 2, 3, 4. 4 to the power of 3 is equal to 64. Now it will give me the answer. Let's check square root can be 2, 3, 4, 5, 6. 5 into 5, 25, 6 into 6, 7 into 7, 8. 8 to the power of 2 is equal to 64. Yes, the answer will be true as 8 to the power 2 and 4 to the power 3 is 64. Yeah, let's now give it example of 16. Let's see how it gives. Yeah, now you can see it is giving me the perfect reasoning. But if I escape this, and when I was asking for 16, it was not able to give me answer. Okay, now it is giving. Now 16 is not a perfect cube. So let's ask it again and again. Yeah, see, now it is sometimes giving me the wrong output also, right? Cube root of 16 is 2, which when cubed gives 16. So here, like it is able to predict somewhere, right, that square root of 16 is 4. So when squared gives you 16. Cube root of 16 is 2. It is somewhere missing that kind of logic. So for that, like you can just attach this thing, and now it will always give you fine results because you have used combination of two techniques, and it is able to give you the perfect results. uh, Anyone wants to give me another number for testing? 21. Let's take 21. Let's skip it. Let's skip it. See, the number 21 is neither perfect square nor a perfect cube. This is the explanation that comes from the COT technique. To check if 21 is perfect square, we need to find number x such that x to the power 2 is 21. There is no whole number that satisfies this equation. Such similarly for perfect cube. Now you are able to understand 6. Let's try 625. Yeah, 625 is perfect square, perfect cube. Now since like I have given it sufficient examples, it will be able to understand it a little better. Any more examples or okay, 1024. Like I can give it as many as I want, but the answer will remain the same.
Excuse me, sir.
Yeah,
I think, sir, in the case of number 625, the output wasn't correct.
is it so? 625 is 25 square, right?
Yes, sir. Right now, the output is changed. Earlier, the output was that it is both a perfect square and a perfect cube.
I got it. Uh, you are seeing. I guess this is perfect example for me to have the understanding of temperature and toppy. So if I am reducing the temperature, also won't work. I guess for the like this gives you an understanding of like LLMs are not perfect in terms of reasoning, but you like if you remember the first diagram that we discussed here, like even if you are giving the prompts, the accuracy max it can go up to is 70, but you can increase this by using more and more prompts. So what like for this case to never happen, we can just give it some more examples. Like here I have given it two few shots, right? We can give it some more shots. I'll just copy paste it. Like the thing that I am trying to explain here is it is not possible that LLM will give you always 100% accurate answers, but you can just improve your prompt a little more better time to time, so that it is able to give you, like I would say, 90% of the times the correct answer. So it has got you picked up that 625 was not a perfect cube. So what we can do is here, let's give another example of, let's not take 625, let's take 1024. Cube roots can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 10, yes. But 10 to the power 3 is 1000. This it is cube Let's improve our prompt here also. Cube root and square root and checks if some number on squaring and cubing is given us output. That number should be proper whole number, and so let's place it right here in this. What square roots can be. What is the square root of 1024? It should be 51517. 5. 32. Yeah, let's have 10 iterations to understand it a little better. Okay, 5 is a valid cube root. So it's giving you one thing wrong. Now see, for 625, it is again giving me a wrong output. Now I can improve my prompt a little better to have it understand. You can iterate over all possibilities of cube root and square root. On squaring or cubing is giving you this output. I will define squaring definition. Number raised to power of 2, cubing number raised to power of 3. Like these are the trips or tricks I am following from COT, chain of thoughts. So let's try it again. Yeah, it's giving me a good answer. Let's retry it again. Retry it again. So now you are able to see, right, how things are improving. Like what I have done here is okay. What I have done here is I have improved the definition of squaring and cubing, just making this little change. Because what I have seen in the earlier response of the assistant was it was giving like 5 to the power 4 as cubing. So if you are just training your prompt a little better, I won't say now it will never give wrong answer for 625, but the possibility is reduced to like next to zero. Got it. Now, anyone have any other doubt or want me to track any another number? Yeah, Swastik, the point is right that increasing the number of examples, LLM will increase the accuracy. I'll like to bring another point here in a little limelight that there is a concept called token limit, and if you are just going to increase the number of examples, that is going to increase the cost for you. So if you see, I can like there is this maximum length of token, and if I go token limits, different GPT models.
Someone asking in the chat section how long the class would continue. Uh, yeah, please, if you can answer.
Shivam, pardon, your voice was not audible enough.
Tanmay is asking how long this class would be continuing.
How long the class will be continuing, it's based on you, I guess. I wanted to discuss two basic techniques, and I'd like to discuss one more example, and will be open to discuss the questions. I guess the class was scheduled for 1.5 hours, right, Shivam?
Yeah, yeah, please.
Yeah. So ideally, 10 to 15 minutes more I'll be taking. So I wanted to discuss. mm, GPT models. Yeah. So this is the page where you can go and take a reference. So if you see GPT-4 Turbo, it has come up with 128K token limits. GPT-4 Turbo 2024-49 was again with this, but this is 8K token limits. That is basic GPT-4. So if you see, right, as you increase the number of things in the prompt, it will gonna increase the token. So this is one thing that you can, I can bring it here for the for your reference. Yeah, I'll be sharing the PPT. And there is one more thing that I'll like to share, that is tokenizer. So in this prompt, right, that we are taking care, if I see there are 295 tokens, and let's say you are interacting with your model, I say 1,000 times in a day. So you are just involving this many times. These many tokens are wasted. And if you just see the costings, right? Let's say GPT-4 model costing. So it shows you $30 for 1 million tokens. So I'm talking about this by 1 million. That gives you this. Let's multiply it by 30. So you are just wasting $8.85 in the prompt itself. So there is another challenge, that you want your prompt to be as precise as possible, because if you are, this prompt is just to give your model a little context, right? So you should not be going and expanding the, like, there is as such no model you can use all the credits that are there for a model. Let's say I'm talking about 128K tokens. You can use 100K tokens in defining the prompt, but that way it's not good for you to go via that approach, because all of your money is getting wasted. I guess that this is pretty clear. Let's take another example. Can anyone in the audience suggest me an example I should be taking for you to have some understanding? Anyone in the audience?
172.
Yeah, Tanmay, are you speaking? Okay. Fine, let's. I'll close the session by discussing one more approach, that is self consistency. Self consistency is a way which aims to improve the greedy approach using COT, as we have already seen in this a little bit. The idea is to sample multiple diverse reasoning paths through few COT. Yeah, I guess we have already discussed this. This is basically combination of COT and few shots. But the different thing is that when I am giving it some examples, that example should be enough for like those examples, it should be exhaustive in nature. So that is the thing. I guess you guys are pretty much clear. So now I'll be opening myself for questions. uh, if you want me to summarize, what we have seen today is understand the importance of prompts, what defining definition of prompts. We have seen two parameters, temperature and topic. Then we have understand four components of a prompt. Then we have seen six different types of tasks that can be covered by the AI models, so that you can write those prompts a little better. Text summarization, question answering, text classification, role playing, code generation, and reasoning. I guess these are all self-explanatory, so I won't be covering it again. Then we have seen some techniques. There are more techniques that can be covered, but for this session, we have seen two techniques in detail, that is few shot and chain of thought. Few shots is just giving the examples to the GPT in prompt, and COT is giving it example of how you can solve the things, or like just triggering the GPT on how it can process the user input and give you the output. So now, then we have seen zero shot COT is just that we are not giving examples, and then you can see like few shot combined with COT. So yeah, this is the things that we have covered. Let me know if anyone have any doubt or